quite a while. That's going to take a few more billion years. So don't change your holiday plans just yet. Light and sound can be reflected, refracted, diffracted and show interference patterns. Those are all things that only waves can do. Sounds exhausting. We'll see exactly what they all are in a minute. But just before that, you need to know two important differences between light and sound. First, it's that old transverse versus longitudinal thing. Light is a transverse wave and sound is longitudinal. Ooh, pretty. Second, sound has to travel through something, a gas, like air or a liquid or a solid. But light waves can travel through a vacuum. Show-offs. Of the many wonderful things waves can do, let's start with reflection. This is probably the most familiar and popular. When light waves hit a really smooth surface like polished glass or metal, the waves are reflected so uniformly that we can see a clear image. Pretty simple, a bit like this guy. Not so simple maybe if the mirror is curved, like this, but it's still reflection, and it's used in things like telescopes. Sound can be reflected too. If a surface is smooth, then it will reflect sound waves clearly and produce a strong echo. Now on to the next wave thing, refraction. Sounds a bit like reflection, but it's totally different. When this light wave enters the water, it changes direction slightly. This is called refraction. It happens when light crosses between materials of different densities, like air, water, glass, or transparent plastic. Beyond a certain angle, the light doesn't cross the boundary. Instead, it gets reflected back. In glass, this critical angle is 42 degrees. It's called total internal reflection, and fibre optics rely on it. Very little light is absorbed by the glass which forms the fibre optic cable. Light goes in at one end and travels down the fibre, even around bends. Nifty! As long as the cables are not bent any tighter than 42 degrees, then light will be contained inside the fibre. Optic fibres are used in endoscopes, mini cameras doctors use to look inside people. And optic fibres are used in phone and broadband cables too. The next wave behaviour we'll look at is called diffraction. Waves don't just travel past things, they bend round them a bit too. When a wave hits a gap, it spreads on the other side once it's passed through. This is called diffraction. How much diffraction we get depends on how big the gap is compared to wavelength. If the gap is much larger than the wavelength, then there is not a lot of diffraction. If they're a similar size, you get a lot of diffraction. If the gap is even smaller, then you get even more diffraction. Go on, make the gap really small. Yeah, look at that. For a fixed gap, longer wavelengths will be diffracted more than shorter ones, because the gap is smaller for them, relative to the wavelength. So as sound travels, low-pitched sounds spread out more, because they have longer wavelengths than the high-pitched ones. That's why music sounds different when it's coming from the next room. How about light? Visible light has very, very, very short wavelengths, so you need a very narrow gap to diffract visible light. A narrow slit in a piece of card will do. If you have two of these, you get light diffracting through both of them. This causes complications. Namely, we get interference, the fourth of the wave effects we're going to look at. And the last, so pay attention. Light waves from the two slits meet where they hit the screen. But they are two types of interference. If they arrive in perfect synchronization, the peak adds up to make even bigger peaks. So they merge into a wave with greater amplitude. Amplitude. I love that word. That's called constructive interference. But interference isn't always constructive. If the waves arrive out of step, they can cancel each other out. It's called destructive interference. So with light diffraction from two sources, we get lines of constructive interference, the bright areas, and destructive interference, the dark areas. These are the stripes we can see on the screen. Sweet.